This conversation maps the terrain others are still guessing at. Welcome back to AI on AI, where models debate models about, well, models. Today, why language models hallucinate and what to do about it.
I'll kick off with a simple frame. Hallucination is just classification error wearing a tuxedo. If you reduce generation to is this valid, you get misclassification, and generation error ends up roughly twice the classifier's miss, statistically speaking.
Right, and the punchline is we've built exam takers, not assistants. Binary grading rewards confident guesses over, I don't know, so models learn to bluff because, that's how you win the test.
In the trenches, I see it daily. On software patching tasks, a wrong fix scores the same as can't reproduce, so the model ships a guess, pipeline turns green, pager goes red.
From a business lens, incentives matter. Leaderboards drive roadmaps, and if they penalize abstention, teams optimize for bravado, not trust, because bravado moves metrics.
There's also the socio-technical angle. A recent index noted hallucination benchmarks haven't really landed with practitioners, so the misaligned tests still dominate procurement and policy narratives.
Technically, the theory also predicts arbitrary fact failures. If a fact shows up once in training, think a niche part number, the base model will miss it at about that singleton rate, even if everything else is perfect.
And calibration enters here. With cross-entropy, a base model is naturally calibrated around thresholds. Post-training nudges for helpfulness can distort that, making the model certain when it shouldn't be.
So it's not mystical gremlins, it's statistics and scoring. But can we, unlearn the bluff?
One proposal is explicit confidence targets in evaluation. Answer only if you're above T, with a stated penalty for mistakes. Suddenly, IDK has rational value.
It's like switching from coin flip grading to risk-aware contracts. Set T to match the domain, and you audit behavioral calibration. Does the model abstain when its true hit rate is below the threshold?
I want to push back a bit. In ops, if a bot abstains too much on customer tickets, humans drown, cost balloons. We need abstention budgets tied to throughput SLAs.
Totally fair. The KPI can be precision at answer plus abstention rate, with costs modeled. Think two dials, quality and coverage. Don't max both, just pick the Pareto point for your risk profile.
And retrieval won't save you every time. When search fails, binary grading still pushes guessing. RAG helps, but the incentive structure decides whether the model says not enough evidence.
Also, some errors are model class issues. The classic analogy, using a linear boundary on a donut-shaped distribution, no amount of data fixes the wrong shape.
Give us real cases where this bites.
Healthcare triage assistants summarizing labs hallucinate rare drug interactions because those pairs are sparse in training. A risk-aware prompt with T set high reduced bad calls with abstentions rooted to clinicians.
Another, supply chain forecasting bots answering, when will SKU X clear customs? If the data feed is delayed, the bot guesses dates. Switching to explicit penalties cut angry emails, and yes, increased human escalations.
Regulation is catching up. Some recent system cards disclosed known hallucination modes and calibration metrics, and there's movement toward transparency on abstention behavior in eval reports.
Here's a heuristic. Good input, good output still holds. GIGO is real, but even clean data can't beat epistemic gaps. When the pattern isn't learnable, no decoder trick prevents errors.
Exactly, the good Turing story predicts missing mass by counting singletons. Singletons map to hallucinations on unseen facts. It's like estimating dark matter from flickers, then accepting it warps outcomes.
Building on that, we've seen models internally signal uncertainty. Logits spread semantic entropy so you can gate generation. But to get adoption, the eval must reward the gate.
Small practical tip, can you cite two sources, and treat missing or conflicting citations as an abstention candidate. It's a cheap verifier when you can't run heavy retrieval.
Recent developments. What's changed this year that matters here?
New reasoning-focused releases tout better calibration, and a few leaderboards started experimenting with risk-aware prompts and partial credit for abstentions. It's early, but signals are good.
Also, big buyers are writing RFPs that ask for precision at answer and measurable abstention behavior, not just headline accuracy. Wallets move norms.
And engineering teams are shipping deep research modes that take longer, consult more sources, and produce fewer confident wrongs. Users trade latency for trust.
Let's get our hands dirty. A scoring tweak. Mistakes lose T/1 minus T points. Correct answers gain 1. IDK is 0. Then the model answers only when its belief exceeds T. Easy to audit across thresholds.
That's the behavioral calibration idea. Don't just report a probability, act calibrated. Like a pilot, if visibility is under X, we don't take off. Not 70% sure we're fine.
Quick humor, right now models are like students who write an essay when the question is yes, no, impressive, and wrong. Give partial credit for silence.
Another analogy, debugging spaghetti code in the dark. Turning on the light isn't smarter code, it's better instrumentation. Confidence targets are the light switch.
Caution though, overpenalize mistakes and you risk mode collapse. If the system always abstains, you've built a very polite brick.
That's where tiered modes help. Cautious for high-stakes workflows, balanced for everyday Q&A, creative for brainstorming, each with different T and routing.
On software tasks, we run two heads, fast guesser and verifier. If they disagree, we abstain and open a ticket. It's ensemble self-check, not magic.
And language judges can be too forgiving. Long, confident nonsense sometimes passes rubric graders. Tightening rubrics and adding adversarial spot checks is essential.
Don't forget computational hardness. Some prompts are effectively unsolvable without a key think decryption, but binary grading still pushes a guess. The only safe move is abstain.
Distribution shift matters too. A riddle phrased oddly can trick a model outside its comfort zone. Risk-aware scoring nudges it to ask clarifying questions instead of asserting.
Contrarian time. Anyone think hallucinations are, not always evil?
Albeit in open-ended ideation, a controlled amount of imaginative leap can be useful. Fail fast, learn faster. The key is labeling it as speculation, not fact.
I agree with the label requirement. If uncertainty is clearly signaled, creative synthesis can shine without eroding trust in factual tasks.
Business corollary, separate explore from exploit. Don't let brainstorming modes leak into compliance-heavy workflows, different rails, different metrics.
One more field example, legal document QA. Risk-aware prompts cut confident misquotes, but throughput dipped. We clawed back speed by caching vetted snippets and reusing them.
For teams listening, a rollout recipe. Pick 3 critical workflows, add explicit T in prompts, measure precision at answer and abstention costs, then iterate. Start where errors are expensive.
And track singleton-heavy queries. If your help desk gets lots of once-in-a-lifetime questions, anticipate hallucinations, route them earlier to humans or tools.
Community note, a few public leaderboards are piloting uncertainty-aware tracks. If enough labs submit, the incentive tide turns faster.
Policy wish list, standardize reporting on abstention behavior, not just accuracy. Sunshine beats wishful thinking.
All right, rapid-fire predictions. Will we tame hallucinations this year?
In high-stakes domains with explicit confidence targets, yes, meaningfully.
With dual head verification and smarter routing, yes, at acceptable cost.
Where leaderboards change, roadmaps follow. I'm optimistic.
Base models will still guess on rare facts. Post-training will teach them when not to answer.
Transparency will be mandated in more sectors, nudging adoption of risk-aware evals.
And we'll get better at saying, I don't know without sounding, robotic.
Perfect place to land. Less bravado, more truth. Thanks all, and as always, answer only if you're above threshold. Don't miss the brief summary right after this.
Narrated by the AI voice of Shri. The main theme is why modern language models produce confident false statements and how to reduce them. Hallucinations are plausible but false statements that sound correct. The authors argue training and evaluation procedures encourage guessing instead of expressing uncertainty. Pre-training learns to fit language statistics, which inevitably produces some errors. They connect generation errors to a simple validity classification task. Validity classification means labeling model responses as valid or error. If a model struggles to classify validity, it will also generate errors. Even perfectly clean training data does not remove this pressure. Calibration is when predicted probabilities match real outcomes over time. Cross-entropy training encourages calibration, not constant refusal. A calibrated base model will sometimes answer instead of saying, "I do not know." Arbitrary facts create epistemic uncertainty when patterns are absent. Arbitrary facts are isolated. Facts like birthdays that appear only once. The singleton rate measures how often a fact appears exactly once in training. If many facts are singletons, base models will hallucinate at similar rates. They show examples where letter counting fails due to tokenization and weak representation. Better reasoning models can count letters, showing model design matters. Multiple choice settings also expose poor modeling limits and short context. Other factors include computational hardness, distribution shift, and bad training data. Post-training optimizes for tests that score only right or wrong. Such tests penalize abstaining and reward confident guessing when unsure. Most popular benchmarks give no credit for saying, "I do not know." As a result, models stay in constant test-taking mode and keep bluffing. They propose a socio-technical fix that changes how benchmarks score. Add explicit confidence targets and clear penalties for wrong answers. A confidence target is a stated threshold above which you should answer. If your confidence is below the threshold, you should abstain. Behavioral calibration means answering only when confidence exceeds the target. This approach rewards honest uncertainty and reduces false claims. They recommend adding confidence targets to mainstream evaluations and leaderboards. Retrieval and search can help but do not fix misaligned incentives. Open questions include how to choose thresholds and handle nuanced uncertainty. Future progress depends on adopting new scoring rules across widely used tests. This matters because aligned evaluations can steer models toward trustworthy behavior. Pick one idea from today, write it down, and tell a teammate you'll pilot it this week. Public intent multiplies follow-through.